Hello everyone, this is Jason from Northeastern Junior College in the Wind Technology program. In this video I'm going to show you how to hook up a small DC motor and a DC fan, and also how to use small solar panels to power those components.
Alright, so we're going to use our battery to create motion. Normally I would solder wires onto these two leads. Okay, so we're going to create this. There's a power source, positive and negative, 9 volts. Okay, we're going to go over to our motor M. So that's the circuit I want to create. I'm going to create this loop. So I have two leads on here, one there and there. So that'd be my two sides of my motor, there and there. So the simplest way to be connect, like we could with a resistor, connect red to one side, okay, black to the other, and it spins. Now these are, I believe these are 5-volt batteries. That means that they're designed to handle 5 volts all the time. I can run it off at 9 volts though, but I don't want to leave it because it will get too hot. Okay, but so that's when I say a 5-volt motor. I think I said battery. A 5-volt motor just means that that's what the voltage is designed to handle. Okay, so in my case, I'm going to put 9 volts to it. You can see the thing is spinning. Put the little piece of tape just so you can see the shaft spin. Okay, so but that's kind of hard to hold. So I'm going to use a breadboard. I'm going to pull my parts out. Okay, normally I would solder it. You guys all know how to solder. We did that in the kids' college. So if you can convince your parents to buy soldering iron, again, fire hazard, so just be careful. But in this case, I'm just gonna wrap a wire, one of the wires from our kits, through that, and okay, so take my two wires. I'm just holding them on there. It's not going to be the best connection, but it'll work for now. So then I have my wires on there. I'm going to hook them into my breadboard. So I'm going to put one down here, and I'm going to just put one up here. Now the breadboard is not connected across this little gap, so I'm good. I'm just on two separate wires in my breadboard. So I'd be on, can connect to these 5. And these 5 are all connected to my motor leads. So to turn my motor on, I'm going to take my battery, I'm going to hook it to one side, just like we have in our circuit. So there's my positive to my motor. I'm going to take my negative, hook it to my motor, and there it goes. All right, and it's just spinning away. I'm going to shut it off. Okay, cool thing about a DC motor is that its speed is dependent upon how much voltage I put to it. So if I put 9 volts, it's going to go really fast. If I put a resistor in series with it, okay, what it's going to do is this resistor is going to take some of the 9 volts, and the rest of it's going to go to the motor. So it should run slower. Okay, straight across. It's going to be full voltage. It's going to be a little bit slower. Now it's kind of hard to tell, but it is running a little bit slower. If I add more resistance into it, like a bigger resistor, so I'm going to add another resistor in there. May not even spin. There we go. So I added another resistor, so these two are taking most of the voltage from my battery. I'm only putting a little bit of voltage on my motor, so it's going to spin very slow. Okay, in fact, it doesn't even have enough, no, barely. Okay, so my resistors act like a restrictor. They slow the current flow through my circuit. Okay, so I just added some resistors in series with my motor. And a very good resistor. So I did 2 resistors in series. My total voltage, 9 volts, sits across all 3 components, so then I get a little bit of voltage on each one. Okay. So I'm going to do the same thing with our fan. Okay, so you have if you look on the fan, it does say DC 5 volts. And it's got a little straight line, meaning it's DC, so direct current. So batteries, solar panels. Okay, I'm going to use our fan and do the same thing. Now the leads may or may not matter. I'm going to hook our fan to our red lead in our breadboard. I'm going to hook our black side to the resistor, just replacing the motor. I'm going to hook this thing up. It doesn't even have enough to really spin. So I've got too much resistance in my circuit. I'm going to take one out. There we go. Okay. So I don't know if you should be able to see that, but so I just replaced my DC motor, and this is a DC fan. It's basically just a motor with blades on it. Okay, but they're really the same thing. I shut it off, turn it on. Okay, now I'm not going to hook this up, but you guys do have a little switch. Okay, you could put this in the circuit instead of me plugging in a wire and unplugging a wire every time I want to turn it on and turn it off. What I can do is I can solder wires onto this or hook wires to this switch and put it in my circuit somewhere. I just need to put it anywhere. Okay, my schematic would change a little bit if I add my switch. And it basically looks like a break. You can see that break there. That'd be my switch if I put it in this top leg between my positive and that one. Maybe I won't be able to do it. Okay, but you can see on the circuit, all it's doing is breaking the circuit. That's all my switch is doing. When I flip it one way, that closes. My loop is complete. I flip it back the other way, it opens up, and my loop is broken. And that would, in effect, turn my fan on and off. The same way that plugging wires into and then unplugging it, it's the same thing. All I'm doing is, this is the cheap switch. This is like a 50-cent switch. So, okay, they're basically the same thing. All right, so I'm going to show you how to hook up your solar panel. We can replace your battery. Now, if you remember, this is 9-volt battery. All right, so it creates 9 volts. If you remember on your solar panel, if you look on the back, it only says 2 volts. Okay, so a much larger object, you do have to use the sun, but it only creates 2 volts. If you remember, I said that your LEDs can only handle about 2 volts of electricity. Okay, so you don't need a resistor at all if you're going to use your solar panel. Okay, so I'm not going to be able to show you this because I don't have any sun in here. But if you hook up if you replace your battery that we have here with the solar panel, okay, it's basically all what it's doing. It's creating voltage. Okay, I can hook it directly into my LED, so I would basically have my solar panel into my LED. Actually, I should have some little arrows on my LED. That's what you should have. That's the correct symbol. So that's what I do. My black lead's coming out. It's going through my breadboard, through these 5 just straight wires right here to my LED. Coming out of my LED, like you can see here, back to my solar panel. So my loop's complete. Now if I took this is what I would like you guys to do, is take this, something real simple like this, and if you just go walk out to a window, all you have to do is turn this thing, watch your LED. If you've got a little bit of sun, don't even have to be in direct sun, just face it out the window, and you'll get the LED to light up. So what that's doing is the sun's rays are hitting your solar panel, generating the voltage. Okay, they're separating the electrons from the atoms, moving them to one side, and then that's what your voltage is. And then when you have this complete loop like we do, then your current flow is going to flow through your circuit, and your LED is going to light up, showing you have light. So there's really cool things you can do with solar panels. You can, if you want to make it more powerful, create more volts. You guys have 2 of these. So what you can do is you can put them in. You can put your solar panels in series. Okay, so I would take one solar panel, have a positive lead and a negative lead. Okay, then I'm just going to put them in series. I'm going to take the next solar panel. I'm going to hook the positive lead to the negative lead of that one. So I'll show you. So what I'm going to do is I'm going to basically take the voltage that each creates, and they're going to add together. So I have red lead, black lead here, since I'm using a breadboard, these 5 are connected. So my black lead is connected to my red lead, just like we have in our schematic. And then I'd hook my black lead in. So what you would see with this is that if this one creates 2 volts and this one creates 2 volts, overall what I would measure is I would see 4 volts positive to negative across from this red lead to that one. So I basically double my voltage by putting them in series. And then I could hook up an LED. I don't think it's not going to work inside. But if you hook these 2 up in series, now you've got a solar array, basically. So you can take them outside, you get twice the voltage, easily light up several LEDs, possibly could light up a motor, or turn your motor. You guys would have to play with that. Probably turn your fan at 4 volts. If you remember, your motor and your fan were both 5-volt motors, or 5 volts. Rated for 5 volts. So giving them about 4 volts, they'll turn on. They just may not spin really, really fast. Oh, another thing, if you guys want to learn more, I found a very cool website. It's called allaboutscircuits.com. I use this in my basic electricity class at the college level, but it has a lot of information, very easy to understand, has a lot of experiments, some very, very good information there. And it's free, doesn't cost you anything. There's an online textbook if you want it. I know you guys like textbooks. But has a lot of cool information, allaboutscircuits.com. It's one of the best websites that you can use.